Okay, having a look at our Year 8 quiz number 4 for the term. So we have the first question where we were given an expression and we have to look at the number of terms, constant term and coefficient of A. So in this case we have 2 terms. Our constant term is the -5 and our coefficient of A is the 4. Then we've got a substitution question. So we're substituting -2 into m squared minus 5n. So we've got -2 that we need to square, and then we're taking away 5 times -2. Now -2 squared is 4. Then we're taking away -10, which means we've got 4 plus 10, which is 14. Then we're going to do some expanding. So we're going to multiply 4g by the g, and then we're going to do the 4g times the k. So we get 4g squared minus 4gk as our answer. Then we're factorising here, so we want to break each of these down into its factors. So 5 times g times k times k. Take 5 times 2 times g. So we're able to circle a 5 in each of them and a g in each of them. So we're able to put the 5g out the front, then the k squared inside minus 2g. Here we've got some index laws questions. So we've got g to the 3 times g to the 6. So we're going to write that as g to the 3 plus 6, which is g to the 9. Then we've got divided by. When we divide, we subtract the indices. So we get d to the 9 take 2, which is d to the 7. Then we've got h to the power of 0, which we know is 1. We've got 5h in brackets to the power of 0, which means that 0 applies to the 5 and the h. So we just get a 1 there. And here we've got the 3 outside the bracket, so that's going to apply to the 2. It'll be raised to 2 to the power of 3. And then we've got k to the 3 times 3. So we end up with 8k to the 9, or we could have written 2 to the power of 3, k to the 9. On our second page, we've got some ratio and rates questions. So the first one is writing an equivalent ratio for 2:3. So I could write 4:6, where I've multiplied each of them by 2. I could have 6:9, where I've multiplied each of them by 3, etc. So I'm just multiplying by the same number, and that gives me an equivalent ratio. Here we're simplifying. So 8:12, I'm looking for something that goes into 8 that also goes into 12, which is going to be 4. So if I do 8 divided by 4, I get 2, and 12 divided by 4, I get 3. Here I've got dollars and cents. So first I want to change them both to cents. So I get 500 is to 50, and that's both cents, so I can cross that out. And then I want to divide them both by the same number. So I can actually divide them both by 50, and I'll get 10 is to 1. Here I've got 1/5 is to 1/2, so I want to multiply them by something that both of those numbers go into. So they both can go into 10. So I'm going to times each side by 10. Now if I've got a 1/5 and I times it by 10, I'll get 10 over 5, which is 2. And if I've got a 1/2 and I times it by 10, I'm going to get 5. Then I've got dividing 2,000 in a ratio of 2:3. So first I want the total parts. If I've got 2 parts is to 3 parts, that's total parts of 5. That means I want to do my 2,000 divided by 5 to get how much one part would be worth. Now when I do 2,000 divided by 5, I'm going to get 400. So that means each of these parts of the ratio I'm going to times by 400. So I get 800 is to 1,200. And I do that check that 800 plus 1,200, does it give me 2,000? Yes, it does. Then I've got, if a map has a scale of 1:50,000, what is the real life measurement for a map length of 3 centimetres? So I'm going to put my 3 there. That means I've times by 3 centimetres on this side. I need to times by 3 centimetres on this side. So I would get 150,000 centimetres. Now I wouldn't normally tell someone a length of 150,000 centimetres. I want to put it into a more appropriate unit. So first I'm going to divide by 100 to change it to metres, and I get 1,500 metres. Now I could also write that as 1.5 kilometres. Both of those answers would be okay. For number 10, we've got a scenario and we want to find out who got the better deal. So we've got Alfred buys 30 cans of Coke for 36, Billy buys 45 cans for $49.50 and Casper gets 50 cans for $62.50. So we're trying to work out who got the best deal, and we can use the unitary method there where we work out what one item would cost. So for Alfred, he would get 36 over 30 would be how much one can of Coke would cost him, and his comes to $1.20. Then for Billy, he's got $49.50 being divided by 45, and that gives $1.10. So comparing those two, Billy has the better deal than Alfred because he's paying $1.20 per can, compared to Billy paying $1.10 per can. And then we're going to check Casper, and he's got $62.50 for 50 cans, and he gets $1.25. So he's actually paying the most per can out of the three of them. So the best deal is Billy on $1.10 per can with his 45 cans for $49.50.